Hello, everyone.
Out of the blue, Raymu, when you think of the hardest substance in the world, what comes to mind?
There might be different answers, but I think most people would think of diamond.
Yes, that's right. As another example, I introduced a material called cubic boron nitride in a video about airships. However, synthesizing boron nitride is challenging, so it's merely predicted to be harder than diamond.
By the way, I remember making a video about diamonds some time ago.
Well, that's okay. The previous video lacked information, and the flow of the content felt off.
So this time, you'll be explaining the hardness of materials again?
Exactly. Please stick around until the end. To begin with, what do you think hardness is?
For instance, I assume a pebble is a familiar hard object? Because even if you exert force on a pebble, it doesn't break or shatter. This might be an example of what defines hardness.
Yes, resistance to damage can be seen as a crucial element in defining hardness. However, there are things that might seem hard to most, but are actually quite fragile.
What do you mean?
For instance, bricks might be perceived as hard, but if you hit or drop them with some force, they'll break. And even the esteemed diamond will shatter if struck with a hammer.
So while objects that are difficult to break can be termed hard, not all hard objects are necessarily difficult to break.
Exactly.
Somehow understanding hardness feels really complex.
Your feeling is valid. Even among researchers, there isn't a universally accepted definition of hardness. We can tentatively define hardness as the resistance of an object to change its shape. But there is no common definition or standard for hardness that can be applied to all materials, from metal to wood, plastic, and concrete. That's why it is said that when thinking about hardness, we need to evaluate it from various perspectives.
Evaluate from various perspectives?
The diamond that is considered the hardest in the world can be shattered with a mere hammer. This fact might feel contradictory, but that's because the understanding of hardness differs. The supreme hardness of diamond is determined when using the Mohs hardness scale. Mohs hardness measures resistance to scratching on a scale of 1 to 10. As you can see, diamonds reach a maximum Mohs hardness of 10.
So from the perspective of resistance to scratches, diamonds are the hardest.
Exactly. This Mohs hardness is frequently used for gemstones because it's ideal for jewelry to remain unscratched. Having a tangible measure of scratch resistance is handy. Also, by employing glass with high Mohs hardness, one can produce watches with faces that resist scratching.
I've heard of that. I always wondered why they didn't scratch. Now I know it's based on Mohs hardness.
On the other hand, the property of breaking without much deformation, as in shattering with a hammer strike, is termed brittleness. As the term suggests, it means it's fragile. Diamonds are composed of many tiny carbon atoms that are closely and powerfully bonded. Therefore, when struck with a hammer, these weaker bonds can snap, causing the diamond to shatter. Thus, breaking in a particular direction is called cleavage, and this characteristic makes diamonds brittle. I've never heard of cleavage before.
How does the brittleness of diamonds compare to other minerals? Usually, rather than comparing brittleness, it's more typical to compare toughness, which reflects resilience.
When it comes to that, it's more common to compare the toughness, indicating resilience, rather than the brittleness that signifies fragility. Toughness and brittleness are almost opposite terms. For example, we say that candy has little toughness, or is highly brittle, because it breaks or chips without much deformation. Easy to chip, easy to break. Lack of toughness, brittle. Caramel stretches and resists breaking. So we say it has high toughness or low brittleness.
That's true, candy often chips, while caramel is perceived as being tough. I think I have a rough understanding of toughness and brittleness now.
Now, the toughness of diamonds and some minerals is as shown on the screen. By the way, I also included the Mohs hardness.
Diamond is the hardest in terms of Mohs hardness, but from a toughness standpoint, jade and corundum are stronger. Looking at this table, it's evident that it's essential to evaluate hardness from various viewpoints.
Exactly. In addition to Mohs hardness, toughness, and brittleness that we've discussed, there are also measures of hardness in terms of indentation, rebound, and impact. There are so many aspects to hardness, but actually, Mohs hardness isn't a particularly significant measure in many contexts.
Why is that? You mentioned earlier that it's commonly used for gemstones.
To put it plainly, the perspective of resistance to scratching isn't frequently practical, and the discrepancy in sensation between Mohs hardness and other measures of hardness can be considered a drawback of Mohs hardness.
What do you mean?
For instance, you might think there isn't a significant difference in hardness between a diamond, which has a Mohs hardness of 10, and corundum, which has a hardness of 9, right?
Well, it's just a difference of 1.
However, when it comes to Vickers hardness, which measures resistance to indentation, diamond scores 7,000 HF, while corundum scores 2,100 HFD. There is a significant difference in those values. By the way, I've mentioned many times that diamonds are brittle and can shatter if you apply instant force with an iron hammer. But if you slowly apply pressure, it's actually the hammer that might dent instead. That's how incredible the Vickers hardness of diamond is.
Oh, I see. So the behavior differs so much between impact and compression? That's interesting, isn't it?
Well, we've deviated a bit from the topic, but I hope I've conveyed that the concept of hardness is made up of many elements and is a simple yet profound world. Defining hardness in one word is difficult, and it is desirable to evaluate it from various perspectives.
This time, since it was a remake, the theme was not new, but I've once again realized the fascinating nature of material hardness.
I think I changed the flow and content of the explanation quite a bit, so I hope those who have seen the previous video enjoyed this one too.
That would be great. By the way, I've been wondering, are you planning to continue making remakes in the future?
At the moment, I don't have any plans for that, but since I don't create videos based on a rigid plan depending on how I feel, I might decide to remake something again. Well, as they say, God doesn't play dice. No one knows what the future holds.
Cheesy remark, minus 495 points.
Since it seems like we might end up rambling if we continue like this, should we wrap it up here?
I'd appreciate it if you could watch the previous videos and also the next one.
Thank you all for watching up until now. Thank you very much.
Thank you very much.